Yeah, very happy to be here. Great talk from Jason, and I feel like he prepared everything for me. Like there's so many things I can actually relate in his presentation. But yeah, so let's talk about trust. That was actually Jason's last slide. What is it going to take for you guys to build trust in AI? And I love the concept of trust because when Nav asked like, why I haven't seen full adoption of network automation yet? I truly believe that trust is actually one of the main issue. As Jason say, I have a lot of gray hairs. I've been around a lot of projects, and I've seen so many of them fail because we didn't have trust. And so I was trying to take, some of all of my, learnings along the way and share that, and hopefully, if we can start talking more about how do we build more trustworthy tools and automation, hopefully as an industry we get better. So, shortly about me, again, I'm Damien. I'm the guy that started the baby that Jason was talking about. I guess, the baby is growing fast. I would put it probably more as a teenager, we're planning on graduating very, very fast. But yeah, I'm one of those guys with a lot of gray hairs that started in this journey a long time ago. So we talk about it, trust. Why is trust so important? I think Jason was talking about this example with the self-driving car. Would you think that if he didn't trust the car, he would have gotten into it? And if another way to see about it is, what if I give you a black box with a red button on it, and I ask you to press this button, I tell you it's going to upgrade everything. Just trust me, it's going to do that. How many of you are going to press that button? And I'll believe nobody. That sounds completely crazy. And you might even ask, like, that's completely stupid. Like, no one would ever build such box. That's so stupid. But the truth is, I think it's what we forget along the way, is that that's the perspective of the user. The user see a black box. But what we've seen, what I've seen, is the guy who actually built that box for he or her, it's not a black box. He knows everything about it, he trusts it. Like, the person that builds it has a completely different perspective on it, which means that most of you, I did so many times, I've been actually building a lot of black box to our users. And I think that's, it's just because we forget that to actually build something that user would trust, it's not just about making it work. It's not just making that work this playbook go from beginning to an end. There's so much more that we need to build, and that we forget along the way, and that, we need to make sure that it's actually predictable, that it's manageable. We need to build some transparency into it. We need to make sure it's reliable. And again, not from the guy who is building it, but more from the guy who's actually the person that's going to be using it, the organization. And we just forget so much about that. And every single time, I forget about it. And so, again, this presentation is about trying to get together and acknowledge that and understand that and keep in mind that we really need to do more than just making it work. We need to making it something that others will trust and will actually execute. So another example, because first I love to use analogy about car, and I feel it's actually perfect with Jason. If someone asks me to build a car from A to B, most likely I will build something like that. It will go from A to B, I guarantee. Now it doesn't have door, I'm not even sure if it has brakes, probably doesn't have lights. It's functioning, but is that a car that you can trust? Is that a car you would actually put your family into? And a real car you would actually trust is probably more something like that, something that is human-friendly, has door, doesn't risk the life of your family every time. And to me, at least, it gives an understanding of like the amount of the difference of work that there is from building something that other will be able to use versus something that I will be able to use. And I think as an industry, the mistakes we're also making is, first, it's actually really fun to build a car. So like, we want to build everything ourselves. We want to do all of that. But is that what elevates us as an industry? So, and again, so for me, the main principle to build trust are, we need to make sure it's predictable. We need to make sure it's manageable, transparent, that people actually understand what it's going to do, that it's simple to use, that we shouldn't have to read a 50-page documentation before being able to use any of the tool. Of course, it has to be reliable. It's like kind of table stake. and then it's human-friendly. So that's what I define as the sixth principle. And what I'm going to talk to you through the rest of the presentation is actually how to make that happen. What does that actually mean to make all of that? And while I don't have the perfect solution, I think there's a lot of techniques and design principle that we can use along the way, and that's what I want to share with you. So we talked about it again. I'm not pretending that everything I built checked all the boxes, and I will say I'm not even encouraging you to try to have like all of it. You know, it's really, really, really hard. If you look in my own garage, there's so many cars. They don't have doors. They don't have wheels. They don't have anything. Like like there's just complete mess on my own. That's actually why I can come here and share some of that experience. But I will say just try to at least get one more of those checkboxes in there. It's a journey. Like no one is actually building a tool from day one that checks everything. So it's more like the end goal far in the distance, hopefully, you know, big enough that we can see it and try to go toward that. So let's talk about, there's three design principles that I want to talk about. And actually, I've heard many of them throughout the week, which I think is great. But I've seen, like, you know, if you're in advance, if you know a lot of, you have a lot of experience in automation, probably sounds obvious. But what I've seen, and even within this community, is that there's still a lot of people that are not familiar with those concepts. Sometimes we take them for granted. I think it's super important to actually spend time and make sure we have the same language. And if we don't share that, then actually I notice it's very hard to actually talk about solution, to talk about how we're going to standardize, because we're coming at it with some very different concepts. So the three design principles that for me are super, super important. The first one is idempotency. Again, it came many, many times, but idempotency is this game changer, this idea that when we run automation, every time we execute, we're going to have the same operation. That was one of the early concepts that Ansible brought into automation. If we explain it for network engineers, to me, idempotency is like a DHCP. Without idempotency, every time the laptop comes in, it asks for an IP, and it will get a different IP. And you can very quickly see how big of a mess that would be. Now, if you have idempotency, the laptop doesn't even need to think about that. It just asks for an IP, and it always gets the same. It's a very simple explanation, but I think what it's important to understand is that if the server was not providing idempotency, then there will be a lot of complexity that we need to implement on the client side to be able to make that work. We'll need to make sure that we store the address that we had previously. We need to know exactly, like, was the address that I got was in this room? Was it in the other room? Like, to me, idempotency, it's a super powerful concept, but it's actually really, really, really hard to implement. It's like, you know, it's not because Ansible makes it easy that it is easy. It is really, really hard. And it's about managing the state. It's about, you know, taking the complexity away from the client and having the client as simple as possible, and then moving that complexity on the server side and on all the infrastructure that is in between. So it's just one of those concepts that as we actually building more tools, we need to make sure that the tools that we have include those concepts and are making it easy for us to build on top. The second one is dry runs. It's such a powerful concept. This idea that even before executing something, you'll be able to see everything that it will do, and then you will be asked the question like, hey, here's what's the diff, do you want to proceed or not? So back to this black box earlier, it's this idea that, you know, you just not have a red button, but you also have a grid button that you can safely press on, and it will say, here's everything I'm going to do if you press on the red button. And I'm sure all of you could see that just with that now, most of you will be okay to press on the red button. So it completely changes the game. But again, so something very simple to explain, but super hard to implement. To give some example, like there's a lot of tools already out there that support dry run mode. Ansible have this, you know, if you use some of their flags, they have the diff and check modes that actually will, you know, usually show you the diff on the config or any change that you make. I would argue that Terraform has seen such a rapid adoption because for Terraform, dry run was a must-have. where Ansible had it more as an option, and Ansible had idempotency as a must, or that was built in from the beginning, and dry run more as a optional things that people could use or not. Terraform, it was built in from day one. Like you could not do something without actually having the dry run. And I think it really showed that the power of having all of that. And then the last one is again Kubernetes that also has that built in. And the last design principle is transactional. We want to make sure that when we have multiple changes, it's not, you're not going to have only part of them applied if something changes, you want all of them. So it's really this idea that if something failed, you want all of it to roll back or not. So if you have many steps, all of it succeed or all of them fail. It is, again, something super easy to explain, but very hard to implement. And through the rest of the presentation, we're going to try to go deeper into how do we actually make things transactional, how do we make them idempotent and dry run. Another thing to keep in mind is kind of those three design principles, they're actually very related to each other. Like if you have something that is idempotent, it's much easier to build a dry run. And by definition, it's also much easier to make it transactional. So like, while each of those concepts exist individually, we should really think of them as working better together. It's like 1 + 1 = 3 more than 1 + 1 = 2 here. So hopefully we start having the same language. By the way, something I forgot to mention earlier, like while this presentation could seem targeted more as builder of automation, I really think there's value also for anyone that is just a user of automation to learn that and to have the same language. Like as a user, maybe you have tools that don't provide that, and maybe you could go back to the team that is actually building the tooling that you use tomorrow and say, hey, could we have more dry runs? Could we have more idempotency in the system that we have? Because I feel like it will greatly improve how the team can use that. So hopefully we're not just targeting or addressing the builders here. The tools that supports all of that, so the more like the implementations are the declarative versus imperative, version control, and testing. So let's talk about that. I think someone yesterday mentioned that a year ago he learned the difference between declarative versus imperative, and he made a really huge difference in his strategy. And I definitely agree that it is one of those, haha moments. Like all of us, I feel like in our journey at some point we discover the difference between imperative and declarative, and it completely changes the game. It's really because the way we operate as human is we just do a suite of steps. And usually when we automate, we focus on that. It's like, what are we going to do next? We focus on action. So if you mimic what humans do, you usually end up with the imperative workflow. They will have a lot of steps, and we'll talk about it. So the declarative approach is we focus on the what. We focus on how it should look like at the end, and we let the tools take care of figure out the steps on how to get there. So, if we look on the left here, the declarative approach will be I go in the CLI, I go into config modes, type a bunch of commands, and then at the end, I have configured the VLAN. Where the declarative approach is more about I will just define the configuration that I expect for this interface, and then the tool will be able to know, like, you will be able to actually check and check if what needs to be done for the interface to be done this way. So you can see here actually declarative is almost synonymous to idempotency. But yet I think it's interesting to talk about them separately because they have different concepts, even if they're so close together. Like, we're definitely with the declarative approach, it's super easy to build something, or it's actually much easier to build something that is declarative versus the imperative way. In terms of tooling, I think it might be interesting to explain also like which tool does what. So again, tools like Terraform has been declarative from the beginning. More the tool like the CLI and NetMiko and everything that really works on CLI is usually more imperative. Even though in so many ways, the configuration of a network device is very declarative. That's why that actually replacing, generating the foot config and replacing the entire configuration has been so powerful because it's by definition a very declarative approach. And just to, my personal take is Ansible can actually do both. And I've seen so many people hating Ansible in this community and talking about how complex it is. To me, it's because you're using it the wrong way. And I think it's not about the tool, it's how you're using it. Like Ansible, it actually could be used completely in a declarative way. That's the only way personally I've been using it. Or you could make a very complex imperative workflow. And one way it's going to be a nightmare, and I argue that the other way it actually works pretty well. So I need Brian to bring a Ansible is not bad t-shirt here. Another example to see that is the imperative method is usually you have to talk to a lot of systems. So here, let's say if I have a workflow that needs to talk to multiple switches and firewalls and maybe systems, sources of truth, I will probably visually look like something like that. And you can see that the complexity increases as I have the number of endpoints or steps. But also like the maintenance of all of that will really grow over time because every time one of the switch vendors change, then I need to update on my workflow. There's just a lot of complexity that comes from that. I like to think of it as the more steps you have in an imperative workflow, the higher the complexity will be, and it will probably grow exponentially, and the level of trust that you have in that workflow is going to decrease significantly. So if you could build a workflow that have 15 different steps, but the thing is, testing that workflow, developing that workflow is going to be a nightmare. And you can be sure that if you fail at the 10 steps, nobody's going to trust your workflow because then it will be a nightmare and it will be almost impossible to implement something that is idempotent, to implement something that is transactional and so on. So the declarative approach takes a completely different approach where we kind of have this level of abstractions where because it's declarative, we need to represent through data. And I think Jason said it very well, like data has been the cornerstone of innovation for this reason. It's because we need data to be able to do declarative workflow. And so if we actually have our source of truth, something that captures the state of the internet state of the system, then we can start talking more about declarative workflow. And if we have a very large workflow that needs to have multiple steps, that will actually give us the ability to kind of breaking down into more smaller steps. And instead of having one workflow that touch all 5 systems at the bottom, we're going to have more smaller workflow, or here I call them agents, but that could be just smaller workflow. They will just be in charge of implementing the idempotent declarative workflow that you want on each of those systems. And that's kind of break down the complexity. Each of them can be developed and tested individually, and it overall really increases the confidence and the trust that you would have in this system. If we bring that back to the design principle, with an imperative workflow, we said about it, it's kind of really hard to make it idempotent. If you have 1 or 2 steps, yes, you can do it. If you have 15, good luck. Where a declarative approach is by design kind of idempotent, it's like they're so tightly coupled. Same for the dry run, same for transactional. Actually, doing transactional and imperative workflow is almost impossible. So we see that we really leverage all of those design principles that we talked about earlier. The second concept is version control. Version control is completely changed the game in automation because it gives us the ability to prepare a change in isolation, safely validate that change, be able to have that change reviewed, and then properly integrated into the rest of the system. And honestly, it's a game changer. And what I've noticed is there's really, 2 populations, the one that understand version control and the one that don't. And it's a big issue in our field because the decision maker, I would argue that most of them don't really understand how important of a collaboration tool it is in our workflow. People will hear about Git, they understand that developers use that, but they're like, yeah, that's just for developers. They don't understand how important version control is as a collaboration tool because they never use that. personally, until I actually start using it, I could not really understand how big of a difference it will make in the process. And I think what's super exciting is that version control, this concept that for every change, we're gonna make a branch, we're gonna be able to prepare something, review, validate, collaborate. It's a really game changer. I think what's super exciting in our field right now is initially it was only reserved to text files because it was only Git. And in the last few years, we've seen many projects, many initiatives to actually start bringing version control to the rest of the stack, starting with the source of truth. Netbox is doing it now. Network to Code is working on it. And that was one of the fundamental, the main design principle of InfraHub is that we wanted to have version control everywhere because it is so important in what we're doing. So I think it's super exciting that as an industry, we're really embracing this concept and moving that. So something to keep in mind, but we should really challenge now that every tool that we use should have this compatibility with version control. Like it's not just about text files anymore. And again, it's more than just for developers. It's collaboration tools. It's about traceability. It's about audit. It's about atomic changes. If we go back to the design principle, version control is all of it. Version control is by definition transactional. It has, by definition, the ability to do a diff, which is the equivalent of a dry run. And because usually we focus more on data in a version control and how we store, it is kind of by definition, super easy to build idempotent system based on that. So again, I hope you see how things come together. And the third one I want to talk about is testing. So testing is so important to build something reliable. And it is, I was trying to explain, it's like I think especially as network engineers that evolve into more automation engineers, all of that, testing is the thing we often left behind and we're not necessarily natural. I think to me, testing, it has the power to be your superpower, but it can also very much be your kryptonite and kill you. And so the mistakes that I've made is, junior engineer, they will usually come, and because someone like me come and say, oh, you need to do testing, they were like, okay, I'm gonna do 100% testing day one. That's a mistake. Most of the time, if you try to over-test early on, it's gonna kill your project because you will not be able to iterate on the design and make sure you're building something right. But on the other side, not having any test is gonna kill your project in the long run. So I think us, as an industry, investing in training and having more like building knowledge around how we're going to build testing in our field, I think is super, super important. So I hope next AutoCon, me or someone else will do a lot more presentation about testing. It's a topic that could fill hours and workshops. And there was actually some workshop on it here, so it's great. But just to make sure we have some similar, again, terminology. When we talk about testing in a very simplified way, not planning to pretend that it's going to be a full course here. Let's say we have unit tests, integration test, and end-to-end test. I think what's important is early on in the project, I would definitely be encouraged to look more maybe at integration test, which is kind of the sweet spot in terms of how much you can achieve, but still keep some flexibility on how things are going to move underneath. And as the project gets more mature, then you want to start building more unit tests in a way that, to me, for example, also it gets to a point where when a project gets too complex, if you don't have the proper unit test, it's going to be really hard to develop new features because every feature is going to take a long time to build and test and all of that. So at some point for me, like unit tests become almost my development environment. And I really help with building the velocity of those projects. And I hear a lot of people, sometimes say, oh, testing is so great, but, it's too complex for my project. Like, we have such, it's like, I cannot automate, I have a snowflake, it's too complex. Usually, if you cannot build tests easily on your software, on your system, on your automation stack, that means you have a problem with your design. That means you need to go back to the whiteboard and you need to actually think on how you'll be able to reduce the complexity of your workflow. Like, go back to imperative versus declarative. It is much, much harder to test an imperative workflow than to test a declarative one, because the imperative workflow is touching so many endpoints and there's so many steps that's going to be really, really hard to test. Or if you actually have something that is more contained, declarative, usually it is also much easier to test and validate, at least individually through integration tests. And I've also done that so many times, like sometimes we just spend hours and hours just redoing the same test manually. And what if you could actually automate, spend a bit more time and actually automate that testing? So just for the last section, I wanted to try to take it even more concrete and try to have actual, kind of tips, I would say, on what you can do tomorrow when you go back to your desk to start implementing some of that. It's going to be a bit of there's a lot of different ideas. There's not necessarily a transition with each of them. But hopefully, I wanted to share as much as I can and trying to make it, concrete so that it's not just abstracted thoughts and recommendation. So the first one, and that's something that we were always saying at Network to Code, is like, there's so much work. You should try to integrate as much as you can and reserve the things that you're going to build yourself to the things that you cannot find somewhere else. And that's what Jason was saying earlier, like, there's so many, for example, orchestration tools out there. There's Temporal that was presented yesterday. There's other tools. We need to stop rebuilding so many, we need to stop rebuilding orchestration tools for every single project. Like, that's the waste of time. And usually that also means that, the level of reliability, visibility, it's not going to get there. So really keep that, like, we need to integrate what we can, build only what we must, because we just don't have enough resources to build everything on our own, unless you work at Facebook or Google, which are probably the only two organizations that can do that. The second one is, as you build, you select tools to integrate and not build yourself, congratulations, you need to now start looking at, do they have what I need to be able to integrate properly into my stack? Do they have the proper interfaces? Do they support declarative behaviors? Do they support idempotency? Are they able to, is that something I will easily be able to integrate into my testing workflow? Do they provide great user experience? And I think among all the tools out there, there's so much differences. Like, it's super important to actually spend some time and label the tool, not just on how speed or how fast they are, but actually more on this complete picture and what they actually provide. Like, for example, in InfraHub, we made the mistake. Initially, we developed our own orchestration system internally. And then at some point, we were like, okay, that's just madness. We need to start integrating something. And we look at Temporal, because it's a great project. And we look at another one called Prefect. And at the end, we use Prefect because Prefect was actually built 100% on Python. And it was the one that would be the easiest for us to integrate into our testing framework. Not because it was faster, not because it was better. Like, it was just, for us, that was so important to have a tool that we could properly integrate into our system, not just for the day it works in production, but for all the development lifecycle. And again, that doesn't say that Temporal is not great. It's an amazing project. But for our choice, our stack at this time, Prefect was the better choice. Now, switching gears, another thing that's super important in my perspective is we need to, and I will say, stepping back a little bit, we need to classify the data that we have in our source of truth. And I usually preach to have what we call the 3 primary attributes or the golden attributes. Like, if everything you have in your source of truth you classify as a role, a function, and a kind, it will solve a lot of your problems. I will make it so much easier to automate. And when I say that, it's not just having that on the device. You need that on IP addresses, prefix, interfaces, BGP session. Everything should have that. But once you have that, stepping forward, what you can start doing is you can start mapping your workflow to actually those statuses and those roles. And where it becomes super important is like a workflow is usually just a way to go from one status to the next. And if you have dangerous workflow, let's say you have a workflow that actually is going to upgrade a network device, then even in your playbook, so it's not super visible here, but what we're doing is we're actually filtering from the beginning only the devices that are in maintenance mode to apply that workflow. And we can do that because we have this status, we have all of that defined in the source of truth, we have that built into the inventory. And so now you're kind of building trust by default because your workflow that is super dangerous, like completely taking a device down, you know that it's never going to be able to run on something that has not been flagged in maintenance mode. So it's another way to think about it. And the last one I wanted to share is this idea also that we need to make it have safe default. Like for example, I mentioned earlier Ansible, they have this way to do dry run if you add the flag --check and --diff. But if I write on Confluence somewhere that you should first run it with with this way and then you will be able to run the other way, no one is going to care the day they forget to do that, the day the network engineer actually didn't read the documentation. If you run the wrong playbook at the wrong time, they're going to blame me nonetheless, even if I did everything right. So my point is, we should make it that the default options are extremely safe and extremely clear in terms of what people should actually expect. So personally, one practice I've been doing is every time there is a playbook, I create 2 of them. I use role to centralize the logic, and I will have one that can be executed without input, that will never make any change, that will just show you all the things that this playbook will do, and another one that will actually make the change. And if it's actually in a very critical environment, I would even ask like double confirmations to make sure that people really want to execute that. But just again, some small tips to finish on that. I think I'm done. There's one more thing I wanted to mention. It's more of a personal initiative we started this week. Is, I don't know if you went by the optional boost, but super important to also think about supporting the ecosystem and supporting all the open source projects out there. Because today, we're only as strong as the project we rely on. So, think about that. If you haven't done it, I think there's a link on Slack. You can sign up, and Upsmill, we're going to donate some money to some key projects. So, with that, thank you very much. And
thanks, Damien. And we're a little over time, so we're going to have people take questions on the break, so they'll find you right after this. So we are going to